Okay, let's go ahead and look at another example of a complex circuit. I'm going to move this over here. All right, so we have an overall circuit here that has parallel and series components again. We have 4 resistors, and we need to figure out what is the current and voltage for each resistor. So we need to start out with what is the V tot, what is the R tot, and what is the I tot. Now, make a note, what kind of circuit is this overall? If you look, overall, it's going to be a series circuit again. The reason for that being is because if we treated this right here as one resistor, the pathway would be only one. There's only one pathway for the electrons. So overall, it's a series circuit just like our last complex one. Okay, let's figure out what our totals are. The total voltage is 34 volts. The total current, since it's an overall series, is going to be found by adding up the resistors together. The first resistor is 4 ohms, plus the second resistor. Now, the second resistor is that complex parallel circuit, so we're going to skip that for a second. Plus the third resistor is 9 ohms. Okay, once we know what the total resistance value is for the parallel circuit, we can add those together. So if we go in here to the parallel circuit, let's figure out what that total resistance is. 1 over 7 plus 1 over 10, and then inverse that. So 1/7 plus 1/10 ends up giving us a value of 0.2428. 1 divided by that value will give us our resistance total for this parallel circuit right here. I'm going to write it inside. It's 4.12 ohms. So this, if it was treated as one resistor, would be a resistance of 4.12 ohms. And that's what we're going to add together to get our total. So 4 plus 4.12 plus 9 gives us a value of 17.12 ohms as my total resistance. Therefore, I is going to be found by taking 34 divided by 17.12, and that gives us our total current throughout the entire series circuit is 1.99 amps. Okay, now that we have our totals, let's go in and solve for our individual values here. Since it's an overall series, current is what's the same in an overall series circuit. And so if the total current is 1.99 amps, it's also going to be 1.99 amps here. It's going to be 1.99 amps here. And then if this were one single resistor, it would also be 1.99 amps. Now, that amp is going to get split in between the two because it has a junction right here, but we'll deal with that later. Let's go ahead and come back here and solve for the voltage drop for the 4 ohm and the 9 ohm resistors, since those are just single resistors. Voltage is found by taking current times resistance. So the voltage drop here at the 4 ohm resistor is 1.99 times 4, which is going to be 7.96. And the voltage drop over here is going to be 1.99 times 9, which is going to be 17.91. Okay, so we've solved for the 4 ohm resistor, we've solved for the 9 ohm resistor. Now we need to go inside the parallel circuit to solve for the 7 and the 10. We've solved for what the R tot is for the parallel circuit, and we've solved for the I tot for the parallel circuit. The last thing we need to do before we move on is we need to solve for what is the V tot for just the parallel circuit. So to find V tot, we take our I tot, which is 1.99, times our R tot, 4.12. So the V tot just for the parallel circuit right here is 8.20. Remember, another way we could have solved for that is this voltage plus this voltage plus this voltage all has to equal 34. And so we could have solved that as well. And let's just double check while we're at it. Let's just make sure we did that right. 7.96 plus 8.20 plus 17.91. That gives us about 34. It's a little bit over, but that's just because of our rounding along the way. So that's fine. Okay, so now that we know our totals for just the parallel, let's now look at the individual resistors. In parallel, the voltage is the same. So if the total voltage of the parallel is 8.20 volts, that also means it's 8.2 volts up here, and it's 8.2 volts down here. So now all I have to do is solve for the current for the 7 and the 10 ohm resistor by taking my voltage divided by my resistance. So for up here, 8.2 volts divided by a 7 ohm resistor is going to give me a current of 1.17 amps. And down here, my 8.2 volts divided by my 10 amps is going to be, or excuse me, my 10 ohms is going to give me an amps of 0.82 amps. And if I did that correctly, the amps on the top and the amps on the bottom should add together to be what my total amps is, which is 1.99. And if I do, you can see that it does. It does add up to be pretty darn close to 1.99. This concludes this video lesson on this example.